Good morning. I'm Muhammad Suhail, and I'll be presenting my net zero house, which is located at 55 Windsor Park Road. This three-story house is located in District 20, which is in Ang Mo Kio, Bishan, and Thompson area, on Windsor Park Road. Being in a tropical region, the temperature of this area ranges from 23 to 31 degrees, and the construction materials used for this house is primarily concrete, wood, and glass. And most importantly, the prevailing wind direction originates from the southeast and the northeast. So the spatial arrangement of the building is created by interlocking four rectangular shapes that are positioned either vertically or horizontally to each other. This layout fulfills the requirement of having shorter sides on both east and west sides, and also avoiding that the direct sunlight is being shined on the both sides. So this is the sun path analysis of the site plan at 1540 hours. Looking at the sun path analysis on the south elevation, you are able to notice that all of the exterior walls facing the west are covered and insulated with green walls. So the purpose of this is to prevent solar heat radiation, which reduces heat gain from within the interior of the building. Here is the calculation of the fixed electrical loads in the net zero house. This is the calculation for the circuit planning and the MCB selection. The total connected load of the residential unit in amperes is 24.635 amperes. The calculated maximum demand of the net zero house in kilowatts is 1360.335 kilowatts. A standard size solar panel can generate about 250 to 350 watts of power with an average daily irradiation. So with 27 panels in place, 6.75 to 9.45 kilowatts of power can be generated per day. So as I calculated previously in the previous slides, the total connected load for the electrical system in the house is 3 kilowatts. The building is orientated towards the prevailing winds to allow for cross ventilation to take place. So you are able to see that the air well, which is located at the staircase core, has an heat stacking effect. The large full height windows or glass doors allows for cross ventilation to take place from the north to the south of the building, and that makes a very comfortable environment for the users to live in. And on the east, there are large trees which would help to insulate the building. The openings on the north and south allows for prevailing winds to cool the interior. The diagram on the bottom left shows the heat stacking effect taking place and the cross ventilation on both sides of the building. Cross ventilation can also occur at the living room in level 1. Many overhangs are being used to provide the building with indirect sunlight. Most of the openings and windows are located in the north and south facade of the buildings, and there is a consistent use of grey tones throughout the building. Here you are able to see the sustainable strategies that are being placed and being used in this net zero house. Here you are able to see that there is an open space with greenery provision, water efficient landscaping, sustainable construction, the use of solar energy at the rooftop, cross ventilation for habitable rooms, the maximum permissible shading coefficient SC value of glass, lighting provision, maximum permissible wall U value, a climatic responsive design, and lastly, the sustainable stormwater management. Here there are many green features and innovations that are in place. One of such are provision of electrical vehicle charging and parking infrastructure, which is part of sustainable urbanism, part of green transport. Existing trees are also preserved. This is to prevent disturbance to habitats. Measures are also in place to mitigate the urban heat island effect through the selection of the hardscape, softscape, and building surfaces. Large windows also encourage the use of daylighting to enhance visual comfort. The solar-ready roof includes the structural readiness, roof layout, and also the electrical readiness of the house. The appliances in the house are energy labeled 4 ticks, 5 ticks. You are able to see that there are green wall modules that are being placed on the left and center, which is right behind the staircase core, are vines crawling from the green roof, which is then placed with solar panels on the roof. There is also a motorized louvered window system located at the first level, right beside the car porch. The louver system will change according to the sun path of the day. Then you're able to see that there is a electric vehicle charging provision, and also the car porch, which is paved by water permeable paving system. So this allows for water to pass through and also for grass to grow over it. The balcony on the second level also allows for the users to do urban farming and produce their own edibles. You're able to see the green wall modules. They're in place on both the east and the west sides of the building. You're able to see that the outdoor deck located in level 1 is shaded by trees and has a very nature-like setting. Here on the side plan, you're able to see that there are 27 solar panels on the roof. So that's it for my presentation. Thank you for listening and have a nice day.